Welcome to BSc Statistics students. In this class, I explain formulation of game problem as a linear programming problem. That is, what is the relation between a game problem and a linear programming problem? I explain in this class, for which I consider a payoff matrix for player A. I am considering payoff matrix for player A. A is having A1, A2, and so on, AI, and so on, AM. M strategies, and player B having N strategies, B1, B2, and so on, Bj, and so on, Bn. With the probabilities, first of all, I consider the payoff matrix, and then I explain the probabilities, and I consider the probabilities. So if we consider the payoff matrix A11, A12, and so on, A1j, and so on, A1n. Similarly, A21, A22, and so on, A2j, and so on, A2n. Similarly, AI1, AI2, and so on, Aij, and so on, Ain, and so on, AM1, AM2, and so on, AMJ, and so on, AMN. If this is the payoff matrix, then if you consider probabilities for selecting the strategies of player A, P1, P2, and so on, Pi, and so on, PM, and the probability of selecting the strategies B, B1, B2, Bn, Q1, Q2, and so on, Qj, and so on, Qn. And as we know, I have explained already in some particular class that if B is playing with one of his pure strategy, for example, B1, B2, and so on, Bn, then what would be the expected gain for player A, which we have discussed? That is, if B selects the strategy B1, then the expected gain for player A is A11 P1 plus A21 P2 and so on AM1 PM. Like that, you have to consider for all the strategies for which I am discussing first of all for player A. For player A, if you consider for player A, then what is the a kind of gain which player A gets? Right, if player B selects a particular strategy, I am writing here B's pure strategy, and A's expected gain. A's expected gain. If player B selects the strategy B1, then A's expected gain is, for example, you consider E1P or G1 is equivalent to B. It is you multiply the column of B1 and with the probabilities P1, P2, PM, with that is A11 P1, A11 P1 plus A21 P2 plus and so on. I am writing last one AM1 PM. Similarly, if player B selects the strategy B2, is it clear, right? Then what is the expected gain for player A, which is A12 P1, A2 plus A22 P2 plus and so on plus AM2 PM. That is, I am considering E2P is equivalent to be G2, the gain from B2, then is equivalent to be, is going to be expressed as A12 P1 plus A22 P2 plus and so on plus M2 PM. So similarly and so on, if you consider nth strategy of player B, then what is the expected gain for player A? A1n P1 plus A2n P2 and so on plus AMN PM. That is, I am considering ENP is equivalent to be GN is equivalent to be A1n P1 plus A2n P2 plus and so on plus AMN PM. So these are the expected gains for player A. If player B uses the strategy B1, this is the expected gain for player A. If player B uses B2 the strategy, this is the expected gain for player A. Similarly, Bn, if player B uses Bn, then this is the expected gain for player A. Then among which now, if you consider the probabilities P1, P2 and so on Pm, of course, I have already explained the properties of probability. All Pi must be greater than or equal to 0 and all Qi also must be greater than or equal to 0, and P1 plus P2 plus and so on plus Pm is equal to 1, and Q1 plus Q2 plus and so on Qn is equal to 1, right? Based on that, player A would like to select one such Pi such that one such particular Pi which maximizes the minimum expected gains. Among these minimum expected gains, player A would like to select one such gain which gives maximum gain to player A, that is maximum gain to him, right? So that is, if you consider like that, the maximin value is going to be expressed as maximin. It is represented, it is denoted by mu underscore is equivalent to be the maximum of player A has to select one such probability Pi among I is equal to 1, 2 and so on m, and such that it is going to be maximizing the expected gain, minimum expected gains. The minimum of with respect to J has to select all these particular strategies, the E1P, E2P, that is all these expected gains, and so on EMP, right? So this is what the consideration of the maximin value, among which what I say, if you consider the minimum of the expected gains, minimum of E1P, E2P and so on, EMP, not EM, EN, I'm sorry, ENP, which is equivalent to the value of the gain mu. If you consider the maximin property and the minimum of this expected gain, one of the minimum of this expected gain will be the value of the gain. As this particular, all this discussions I have explained very clearly in one particular class. The minimum of these E1P, E2P, ENP gives you the value of the gain. That is what exactly the argument of game without saddle point, by using the certain probabilities, some kind of probabilities P1, P2, Pm and Q1, Q2, Qn. Here the P is would like to calculate which maximizes the minimum expected gain, for which minimum of these values must be the value of the gain, which means every value E1P is greater than or equal to mu and E2P is greater than or equal to mu and so on, ENP is also greater than or equal to mu. That which means every particular these expected, all these expected gains are greater than or equal to the value of the gain mu. That is the argument for from consideration of the maximin value, right? Maximin point. So therefore I am writing in terms of equation, that is A11 P1 plus A21 P2 plus and so on plus AM1 PM, which is greater than or equal to mu, that is E1P greater than or equal to mu. Next E2P is greater than or equal to mu, which means A12 P1 plus A22 P2 plus and so on plus AM2 PM, which is greater than or equal to mu and so on. I am writing the last one, that is ENP, that is A1N P1 plus A2N P2 plus and so on plus AMN PM, which is greater than or equal to mu, right? If you consider this, then what we have to do is, and also you consider that is to, you have to formulate the linear programming problem, and also I am considering P1 plus P2 plus and so on plus PM is equivalent to be 1. for all these equations, inequations and inequations, what I do is I divide with mu, the value of the game mu, and so that I write the all inequations in this form. First of all, P1 plus P2 plus Pm. If you divide the values with respect to P1 plus P2 plus Pm, then that is for the equation, then you will get P1 by mu plus P2 by mu plus and so on plus Pm by mu is equivalent to be 1 by mu, right? And remaining all the equations, all the inequations, that is greater than or equal to inequations. A11 into P1 by mu, I am dividing here, right? Plus A21 into P2 by mu plus and so on plus AM1 into Pm by mu, which is equal, this is greater than or equal to mu by mu, it is 1. And similarly second one, A12 P1 by mu plus A22 P2 by mu plus and so on. I'm sorry, AM2 Pm by mu, which is greater than or equal to 1. Similarly and so on. The last one, A1n P1 by mu plus A2n and so on, A2n P2 by mu and so on plus Amn Pn by Pm by mu, it is greater than or equal to 1, mu by mu 1, right? In this entire equations and inequations, if you consider for example 1 by mu is equal to x naught and P1 by mu is equal to, let us consider, we are assuming the values, P1 by mu, let it be x1, and P2 by mu, let it be x2, and so on. Pm by mu, let it be xm. So there are m variables. I am considering x1, x2, and so on xm, and x0 is the value in the objective function. I consider in the objective function. I'll show you. The value of the game mu, it is for example, it is for player A, it is maxi-min value. The maxi-min value, from the maxi-min value for player A, mu is going to be obtained. Mu is the value of the game. So in terms of player A would like to maximize his value of the game. That is for example maxi-min value. Therefore maximizing mu. If maximizing mu, which is how to represent 1 by mu, it is minimizing. Maximizing for mu, which represents minimizing, this which implies minimizing 1 by mu, that is x naught, right? Clear? So therefore now what I am writing, the first equation, you see, this is I am converting as the objective function, right? So convert in terms of objective function. Minimizing 1 by mu is equal to, that is what this is equal to x0, x1 plus x2 plus and so on plus xn. That is x0 is equal to x1 plus x2 plus and so on plus xm. Is it clear? Minimizing 1 by mu is equal to x0, that is minimizing x0 is x1 plus x2 plus and so on xm. This is, let us consider objective function. Now then you consider, if you consider if you convert all the inequations now by considering the constraints, that is subject to the constraints, if you consider A11, I am writing here A11, this is x1, this is x2, this is xm. So therefore A11 x1 plus A21 x2 plus and so on plus AM1 xm, which is greater than or equal to 1. First constraint. Second one, similarly A12 x1 plus A22 x2 plus and so on plus AM2 xm, which is greater than or equal to 1, and so on. The last one, A1n x1 plus A2n x2 plus and so on plus AMN xm, which is greater than or equal to 1. And obviously all x1, x2 and so on xm which are greater than or equal to 0. Right? So this is what the conversion of game problem into linear programming problem, where x0 is 1 by mu and x1 is p1 by mu, x2 is p2 by mu, and xm is pm by mu. So therefore none it is the for player A, this is what the linear programming problem. For player A, minimizing 1 by mu, that is x0, is equivalent to x1 plus x2 plus and so on plus xm is the objective function. Subject to the constraints, these are the subject to the constraints greater than or equal to, all greater than or equal to constraints. And x1, x2, xm greater than or equal to 0. Clear? This is what the relation between game to LPP for player A. Similarly, for player B. What is for player B? Oh, I am writing here for player B. For player B, it is maximizing 1 by mu. Just by seeing this, we can write. I am considering y0 is equivalent to be y1 plus y2 plus and so on plus yn, where y1 is equal to, y0 is equal to 1 by mu. Okay, because mu is the value of the game. In terms of player B, it is supposed to consider from minimax. The minimax value, it is going to be considered. The value of the game, if you consider as in terms of player B, it is loss. Loss is going to be minimized. The minimizing mu for player B, it is required to consider minimizing mu. That is maximizing 1 by mu. Clear? Minimizing mu, which is nothing but maximizing 1 by mu. You consider mu is for player B is loss. For player A it is gain. For player B is loss. Right? So therefore, as the player B is supposed to minimize the value of the game mu. Okay, that is loss. And hence maximizing 1 by mu. It is equal to y0. Therefore, y1 plus y2 plus yn, where y1 is equal to q1 by mu, y2 is equal to q2 by mu, and so on. Yn is equal to qn by mu. With these values, the constraints are subject to the constraints. That is constraints. I am writing constraints. Subject to the constraints. The constraints are a11 y1 plus a12 y2 plus and so on plus a1n yn. It is less than or equal to 1. And similarly, a21 y2 y1 plus a22 y2 plus and so on plus a2n yn is less than or equal to 1, and so on. The last one, if you consider m1 y1 plus m2 y2 plus and so on plus mn yn is less than or equal to 1. These are the constraints, and obviously all y1, y2 and so on yn which are greater than or equal to 0. So this is the linear programming problem for player B. This is linear programming problem for player B. This is linear programming problem for player A. Hope you understand. This is what the relation between a game problem into a linear programming problem. It is a conversion. It is a relation between game problem and a linear programming problem. Hope you understand. This is the discussion of game to linear programming problem. Thank you. Thank you very much.